Now putting x is equals to minus 1 upon 2 and solving this particular equation, 3 into 1 upon 2 to the power 2 plus 2k, substituting x as minus 1 upon 2, so minus 1 upon 2 minus 3 is equals to 0. This plus minus will become minus. Now solving further, we get k is equals to minus 9 upon 4. So for k is equals to minus 9 upon 4, the root of this particular equation is x is equals to minus 1 upon 2. Now let's move to question number 5, and second part of the question number 5 is x square minus a plus bx plus k is equals to 0, and the root of the equation is, the root given for the equation is x is equals to a. We have to find the value of k. Now putting x is equals to a in the equation, so x is replaced by a, so a square. Now this x is replaced by a, so multiplying by a will yield in a square and minus ab. A square will get cancelled. Now we get k is equals to ab. So for k is equals to ab, the solution of this equation is x is equals to a. Now let's move to the last question of this exercise, which is, you have given an equation px square plus 7x plus q is equals to 0, and the roots of the equation are given as 2 upon 3 and minus 3. You have to determine the value of p and q. Now simply we substitute x is equals to 2 by 3 in the equation, and since x 2 upon 3 is given as the root of the equation, so equation should become 0. Now putting x is equals to 2 by 3 and solving, taking 9 as LCM in this step, and solving, we get 4p plus 9q is equals to minus 42. Now again substituting x is equals to minus 3 in the equation, we get 9p minus 21 plus q is equals to 0. Taking 21 to the opposite side, it will become plus 21, so 9p plus q is equals to 21. Now multiplying by 9, 81p plus 9q is equals to 189. This equation is multiplied by 9 just to solve both the equation and to get the values of p and q. We are using elimination method, so to eliminate p or q, we have to multiply this equation by something. So I have multiplied by 9 because 9q is here, 9q will be also in this equation, so 9q will get cancelled on subtracting. Now subtracting both these equations, so we will get minus 77p is equals to minus 231. Now minus will get cancelled, so p is equals to 3. Now putting this value of p in the equation 1, which is 4p plus 9q is equals to minus 42, and solving, we get q is equals to minus 6. So q is equals to minus 6 and p is equals to 3. These are the required values. Now moving ahead, we move to exercise 5.2, and the first question of 5.2 is 4x square is equals to 3x, and you have to determine the roots of this equation with the help of factorization. So simply we transfer 3x to the opposite side, so it will become minus 3x. Now taking x as common, we will get x is equals to 0, and on solving this equation we get x is equals to 3 by 4. Now let's move to the another question third, part 1 of question number 3, which is x square minus 3x minus 10 is equals to 0. So this 10 is called constant term and the coefficient of x square is 1. Now multiplying this constant term by 1, we will get 10. Now you have to break 10 into two such parts whose multiplication is 10 and whose addition or subtraction is 3. So we can break 10 in two parts like such that 5 into 2. So 5 minus 2 will result in 3 and 5 to the will equal to 10. Now breaking 3 into minus 5x plus 2x and taking common in this part we'll take common as x, in this part we take 2 as common, and solving we get x is equals to minus 2 and x is equals to 5. So these are the roots of the x, roots of this particular equation. Now heading to the next question, we will take up first part of question number 6, which is 6p square plus 11p minus 10. Now 10 is the constant term, so we will multiply 10 by 6, we will get 60. Now 60 can be obtained by multiplying 12 into 5, 10 into 6 and 15 into 4. But we will take 15 into 4 just because 15 minus 4 results in 11. And on solving, we get p is equals to minus 5 upon 2 and 2 upon 3. So these are the roots of this particular equation. Now again moving to the next question, which is question number 12. We have given 2x square minus 9x plus 10 is equals to 0. Multiplying 10 by 2 we will get 20. Now 20 can be obtained by 10 and multiplying 10 to 2 and 5 to 4. Since we have to obtain 9, so we will select 5 into 4, because adding 5 and 4 will result in 9 and 5 4s are 20. So both conditions are satisfied. Now we can easily solve this question, and we get x is equals to 5 by 2 and 2 as the roots of the given. Now moving ahead, we go to question number part first of question number 11, which is x square minus bracket 1 plus root 2x plus under root 2 is equals to 0. Now what we will do is we simply open the bracket. So opening the bracket will reverse the sign of both 1 and under root 2, so both will become negative, and also we have to multiply by x. So 1 becomes x and root 2 becomes under root 2x, and both are negative. So taking x as common here, we can take under root 2 as common, and on solving we get x is equals to 1 and x is equals to root 2. So these are two roots of the given equation. Now moving to the next question, second part of question number 16. X plus 1 upon x is equals to 41 upon 20, 1 on 2 or 1 upon 20. So now taking x as common, x square, we get x square here plus 1 is equals to 41 upon 20. Now cross multiplying, we get 20x square plus 20 is equals to 41x. Now taking 41x to the opposite side, it will become, now multiplying 20 by 20 we will get 400. So since 400 is a big number, so we break 400 into smaller pieces or divide 400 by 2, and this division continues up to 1. So now we can see that we have these many parts of 400. Now 400 is broken into its prime factors. So now if now taking these 4 2's and multiplying them, we will get 16, and these two 25 when multiplied, these two 5's when multiplied, they yield 25. So 16 into 25 will result in 400, and if we add 16 and 25 we will get 41. So 41 can be broken into 16x minus 25x plus 20 is equals to 0. Now 41 is broken into 16x minus 25x. Now taking 4 as common, we will get 5x minus 4. Taking 5 as common, we will get again 5x minus 4. Now 5x minus 4 is taken common, so will result, so we will get only 4x minus 5. Now equating both these terms to 0, we get x is equals to 5 by 4 and x is equals to 4 by 5. So these are the roots of the given equation. Now let's move to the second part of question number 18, which is x plus 2 divided by x plus 3, 2x minus 3 upon 3x minus 7. Now simply we have to cross multiply So we'll cross multiply x by 2 by 3x minus 7 and 2x minus 3 by x plus 3, and on cross multiply we can see that x is multiplied by 3 and x is multiplied by 7, so 3x square minus 7x. Now 2 is multiplied by 3 and 2 is multiplied by minus 7, so we will get this. Similarly, same steps we can multiply these two terms also, so we'll get now 3x square and 2x square. 2x square is transferred to the opposite side. Minus 7x plus 6x will become minus x, plus 6x minus 3x will become 3x. When 3x is brought to the other side, it will become negative. Minus 14 and minus 9 when brought to the other side, it will become plus. So on solving we get x square minus 4x minus 5 is equals to 0. Further on factorizing, we get x is equals to 5 and x is equals to minus 1, which are the roots of the given. Now let's move to the second part of question number 20, which is x plus 1 upon x minus 1 plus x minus 2 upon x plus 2 is equals to 3. Now taking LCM x minus 1 and x plus 2. So x plus 2 is multiplied by x plus 1 and x minus 1 is multiplied by x minus 2. And again we multiply both these terms. So we get plus x square plus 2x plus x plus 2, x square minus 2x minus x plus 2. So these plus 2x minus 2x will get cancelled, plus x and minus x will get cancelled. So x square will add up to yield 2x square, and 2 and 2 will add up to yield 4. Now this whole term is cross multiplied by 3, so we'll get x square plus x minus 2, and now again multiplying by 3 in the bracket, we will get 3x square plus 3x minus 6. Now taking 2x square to the opposite side and 4 also to the opposite side, we get x square plus 3x minus 10 is equals to 0. Now this equation can be solved by factorization.